In this video, you're going to launch a web server on AWS that's accessible from anywhere on the internet by creating a VPC with a public subnet and deploying an EC2 instance inside of it. But before we do, make sure to hit that subscribe button if you want to stay updated on the latest cloud, DevOps, and even AI content. Let's go. But before we start this lab, there's a lot of theory that we need to cover. The AWS cloud contains many regions. The region that you choose to deploy your resources in depends on where you believe most of your users will be. If you believe all of your users will be in Sweden, you should deploy your resources in the region EU North 1. If you're not sure, it's recommended to deploy your resources in US East 1, AWS's oldest and most mature region. Now this region, like many others, is composed of many availability zones, physical data centers where you can deploy your web servers, physically deploy your web servers and your applications. In any case, millions of other people can also deploy their resources in that same region, which is why AWS divides the cloud region into private networks that can separate your resources from everybody else's. Each private network is known as a virtual private cloud because it creates a private, isolated network in the cloud just for you. Now, if we consider that a VPC is a network that isolates and connects all your resources across the entire region, the actual resources deployed per availability zone exist in a placement within that network known as a subnet. It follows that a VPC spans an entire region and a subnet spans a single availability zone. This is an important distinction because not all resources should be accessible from the internet. Public subnets have a route to an internet gateway attached to the VPC that allows their underlying server to receive public traffic. The server is known as an EC2 instance, or an EC2 server if you will, and they're typically used to run your applications or any custom software that you deploy into them. Private subnets don't have that route to an internet gateway, so they contain resources that should never be directly accessible from the internet, like databases. That's it. All right, this is going to be a lot of fun. Let's actually implement this. We're going to create a VPC that's going to isolate all the resources needed to launch an EC2 web server, and then we're going to connect to that web server through our local machines. This is going to be very rewarding and we're going to learn a lot, but there is one prerequisite. You need to have an AWS account already set up and then logged in to your AWS Cloud Console so that we can just get to work. If you don't have that set up, please make sure to go check out my AWS setup video. You can find it by just searching it up on YouTube. It's called AWS Setup, Create IAM User and Configure CLI. We're not going to use the CLI for this lesson, but anyway, let's just get cooking. Start by going to search and search up VPC. Click on VPCs. Alrighty, and you should notice a default VPC is already created for you that is scoped to whatever region that you're operating in. In my case, it's US East 1, North Virginia. Your region may be different, and it doesn't really matter for this tutorial. We're going to create a VPC scoped to whatever region that we're currently going to be deploying resources in, and we're going to create a VPC and more. All right, now let's remember that a VPC is a virtual boundary that isolates all of your resources into your own segregated network that is separate from any other VPC existing in that region. Okay, this is a virtual boundary that completely separates all your resources from everybody else's. Now, there are 4 subnets within this VPC, and let's recall that a subnet is a segment within this network that organizes resources by availability zone. So while a VPC is scoped to one entire region, in this case US East 1, this subnet, each subnet here is scoped to a single availability zone. You'll notice that each availability zone contains a public subnet and a private subnet. That is a very common practice, and before I explain why that is, let me go over what a public subnet is and a private one. And so a public subnet, as you saw in the theoretical part of this video, is one that's connected to an internet gateway, meaning that anything that you deploy in the subnet, let's just say it's an EC2 instance, a web server, the IP address of that web server would be public, and anybody from the outside would be able to connect to it. This isn't necessarily bad, but let's just say you had many applications, many microservices, each one running in an EC2 instance. Well, then you increase the attack surface by which people can exploit your server vulnerabilities, and you would need to apply various security rules and protection to each server. And that's just really, really hard to maintain. And so instead of applying all of these security rules to many, many web servers, what you would do is put those web servers in a private subnet that has no direct access to internet gateways, that can only be accessed by other resources within the same VPC, not to the outside world. And then in the public subnet, put one single load balancer that is hardened by all of these security rules, that is then able to receive traffic from the outside and distribute it to services that are in a protected private subnet. So that is a very common practice. And you usually want to have one public, one private subnet pair per availability zone, and this is needed for high availability. You know, in the event that one availability zone has like a power outage or something, you want your other services to also be live. You never want to put public and private subnet pairs, all of them in one AZ. That's just bad design. So that's what it is. For the purposes of this video, what we're going to do is just have no private subnets, and therefore one availability zone. Okay, we're going to deploy our EC2 instance in a public subnet, which contradicts everything I just told you, but just to keep things simple. Okay, now the name for the VPC, if you recall that a virtual boundary is one that isolates all your resources into their own segregated network, well then what is a good practice to segregate one set of resources from another set of resources? A common one is when you've deployed all of your applications, softwares, and operators in a dev environment, and then you want to deploy them in a prod environment. So a dev VPC would isolate the dev resources, and a prod VPC would isolate the prod resources. Okay, we're just going to create a VPC called tutorial dev. And it follows that everything else inherits this naming, the subnet and the route tables. Now IPv4 CIDR block. Here, ultimately, we decide the IP range that is going to determine what the IP address will be of every resource in this VPC. We use the IPv4 CIDR method in order to do that. IPv4 ensures that the IP address of whatever resource is always going to be 32 bits, where each number in this case is going to be 8 bits, 8 bits, 8 bits, 8 bits. And so while IPv4 ensures it's 32 bits total, CIDR is a notation for describing how to divide those 32 bits. So here we have the /16. This is a prefix length that says the first 16 bits, so the first two numbers must be fixed, which means the remaining numbers can vary from 0 to 255. Why 255? That's just the size of an 8-bit byte. All right, so in this case, any resource in this VPC can have IP addresses that range from 10.0.0.0 to 10.0, forget the HTTP over there, 10.0.0 to 255. All right, how many possible combinations of IP addresses does this range produce? Well, you just got to do 255 times 255, 65,000. Close enough. All right, we're done that. That's all we need to do. Go ahead and create your VPC. All right, view VPC. All right, and now within this subnet, in this VPC, we're going to create an EC2 server that is physically deployed in this availability zone. All right, so remember that while these entities are kind of like virtual logical concepts, we are still physically deploying things in physical data centers. All right, and we're going to do it within the boundary of this subnet. So now go ahead and search up EC2. And we're going to launch an EC2 instance. And the EC2 instance, I'm just going to call it web server. It is a web server that is going to house a web application. We're not going to deploy an application in the server for this lesson. That will be something we do later. And this lets you choose which operating system and pre-installed software will run on your EC2 instance when it launches. You want to choose one that allows for a free tier. Okay, moving on, nothing interesting here. Choose t3.micro, which also supports a free tier. And now we're going to create a public-private key pair, an SSH key pair, if you will. Why? Let's recall the goal of this lesson, which was to launch an EC2 instance in a public subnet so that we can connect to it directly. We haven't placed this EC2 instance in our public subnet just yet. We'll do that in just a second, but ultimately that would make this web server public-facing, which means we'll be able to connect to it directly. And we're going to connect to it using SSH. Now, SSH, as opposed to HTTP, which is typically reserved for your end users when they want to use your app, you know, all the encryption and authentication is automatically handled by browsers. But in this case, as developers, because we want to start, you know, debugging and troubleshooting right away, the easiest way to do that is using SSH. You just SSH into your server, you're connected to it, and then you can run all sorts of commands to see what's going on. How will we gain access to our web server using SSH? That's where we need to create a new public-private key pair. I'll explain how that works in just a second, but what we're going to do is give our key pair a name. I'm going to call it Rayan Keys in this case. Feel free to use whatever naming you want. And I'm going to create a key pair, and what that does is it gives me a private key, all right, that I'm going to keep handy over here. And what it's going to do is put a public key on the EC2 instance side. And so ultimately what happens is when I try to SSH, when I try to connect to my EC2 instance using this private key, my SSH client is going to generate a signature from this private key, send it over to, I guess, AWS. It's going to verify that signature against the public key that it has for that EC2 instance. And if everything matches, it will allow us to connect. A very simple way for us to connect to our web server and be able to troubleshoot. So keep this handy. And what you're going to do is you're going to edit this. Actually, before we edit this, we're going to allow SSH traffic from anywhere. Anyone with any IP address, provided that they have the correct private key, will be able to connect to our EC2 instance, just to keep things simple. But now we need to edit the following. The VPC that we want this to be in is the one we just created, tutorial dev VPC. All right, because this one has the public subnet that we need it to be in, and we're going to need our resources to have a public IP so that, for instance, our EC2 instance can have a public IP by which it can be reached. All right, this we already talked about, being able to SSH from anywhere. And now we look at configuring storage. So by default, your EC2 instance is going to be connected to 8 gigabits worth of storage, and this root volume by default will be mounted to your EC2 instance, and that's going to contain all the operating system software that's needed to get your EC2 instance up and running. And you never want to mix that with your own, I guess, application-related data. If you had an app running in your instance in your web server that needs to persist data, then what you would need to do is add a new volume that also has storage, an EBS volume, if you will. And then you can configure your app to persist its data here or back up the data here. So that way, in the event that the EC2 instance shuts down for whatever reason, your application data will still live inside of this EBS volume. All right, we've done everything we need to launch our EC2 instance in this public subnet within this VPC. Let's just have me stop talking and launch it. All right. So now we go to the instance. What do you know? It's running. All right. And so now here we see the public IPv4 address. And so what I want you to do is note the private key that you just downloaded. All right. Mine is in my downloads folder. Let me just clear the output. Now, Windows users, in order to accomplish this step, what you need to do is use git bash, okay? Because you want to be able to run the same commands that I'm running in my Mac terminal. And so the private key that you're given from AWS by default is going to have no restrictions on who is able to read its data, I guess. And if there are no restrictions on a private key, when you try to perform that SSH process, it's not going to work. It's going to reject it. And so you can add restrictions to a private key so that only you, the owner of it, can read it by running this command chmod 400. Let me just expand this guy. Chmod 400. So you'll only be able to run this, Windows users, if you're using git bash and then your private key. So the one I just downloaded was rayankeys.pem. All right. And now what I'm going to do is SSH into my EC2 instance, connect to it by saying ssh.I. I means we're about to provide an identity file, in this case, a private key. Then you reference the private key itself, rayan.keys. And then we're going to say EC2 user. So this is the username of the account that you're logging into on the remote server. And EC2 user is just the default username for Amazon Linux instances. I didn't just make it up. And followed by the user, you provide the public IP address that we can use to reach our EC2 instance. And now given the private key and the username, will we be able to authenticate to this web server? We're just going to click yes. I trust the authenticity of this host. And if you see this bird or whatever animal, you're done. So that was pretty much it. We can now run whatever commands we want in that EC2 instance. And assuming we had, apps or whatever deployed in it, we can run some troubleshooting stuff. Pretty cool. I was about to finalize, but we need to do some cleanup so that we don't get charged money for launching all these resources, okay? So we should still be within the free tier for now. Click on this web server and please terminate it. You don't want this to be running all night. Worst comes to worst, you'll get charged a few cents just for this, but no need for that. Terminate your web server. Once you've terminated your web server, you can then terminate your VPC. And once you do that, you should be all cleaned up. Actions, delete VPC. Unable to delete, it's still relying on us removing the web server first. Let me just make sure that's been deleted. 0 running, cool. Actions, delete VPC. Can't delete it yet. This is still terminating. It's shutting down, so we'll have to give it a few minutes for it to do that. I'll be back in a second. All right, this is me a few minutes later. Let me just refresh this guy. Try to delete it again. Cool. Type delete in the field. Again, really important you clean up. You don't want to be charged money for no reason. And that's pretty much it. And that's where I'm going to wrap up this video. You were able to create a VPC that isolates all of the resources inside of it, a public subnet that's internet facing. And so we launched an EC2 server in that public subnet, which allowed us to SSH into it from our local machines. And now the sky is the limit. I hope you enjoyed this video. If you did, please make sure to hit that subscribe button and do make sure to check out my website, rayanslim.com. If you're into cloud content, you'll definitely enjoy DevOps content as well, where I'm advertising my Docker and Kubernetes courses. All right, see you in the next one.